Today's video tutorial is very important. I can't stress this enough. This is very important topic. If you miss this one video tutorial going forward, you might feel other video tutorials as complicated or difficult to understand, but in fact these are very simple things. If you understand these basic concepts, going forward everything looks so straightforward. Okay, so let us discuss arrays and pointers and how we can use arrays and pointers with functions. Okay, so I have a simple variable. I'll assign 5 to it. I'll take a pointer variable ptr star ptr. We already know a pointer variable is a variable which holds address of another variable. So ptr is equal to address of num. Let me print out the value present inside ptr, which holds address of variable num. So if we append star to it, it will display the value present at that address ptr. Okay, this is nothing but writing ampersand num and star ampersand num. That's it. It produces same result. But let's output the result using pointer variable, which is ptr in this case. So I'll write star ptr and ptr. So the first printf prints the address of variable num, and second printf prints the value present at that address, which is 5. So let's compile and run this program. Oops, I have to put comma here. So let me compile and run this, and it's working now. So first output is the address of variable num and the second output is value present at that address. Okay, simple. I know that you guys already know these stuffs. Simple, right? Now let me print the base address of an array. So let me take a array of 5 elements in it, 0 to 4, 5 elements. So now let me print out the base address, that is the first address of first element. In this case, the element is 1. We need to print the address of that first element. Okay, so base address is ampersand num of 0. So we also know that the variable name, array variable name itself holds the base address. Let's check that. So both these printf statements should output the same address, which is base address of this array. So let's check that out. And it's working. So both of these printf statements are printing the base address of this array where the element 1 is present. So let's print the value present at that base address, which is 1. We already know that. So let me output a message, value of num of 0 is equal to %d/n. Let me have a /n to begin with this sentence. So I'll have num of 0. That's how we access array elements, right? So now let's access the same using just the name. So array variable name num holds the base address. So append it with star, that is value of operator. So that would fetch the value present at that address, right? So it should print 1, 2. So one more thing, let's write star of num plus its index value, which is 0. So 1 is present at index 0. So all these three printf statements should print the value 1, which is present, the element is present in base address. Okay, so let's check that. Okay, so all these three statements output the same result, which is 1, which is present at the base address. So let me output the second element in this array. That would make this concept clear, which is 2 here. So we access it using num of 1. The index is 1 here. So I'll remove this middle statement. I'll write that afterwards. So now star num plus 1 should output 2, that is second element in this array. And it's working. So in fact, let me tell you, in fact, num of 1, whenever you write num of 1 or anything, num of I, the compiler converts it into star num plus I, because pointers are, it's quicker to operate with addresses than these variables. Okay, So now let me take I for loop. So let me print all the elements of the array once and show it to you. We have been using these for loop and printf statements in many of the programs already. So I don't have macros here, so I'll directly input I less than 5. So num of I. So I varies from 0 to 4. So it should just print the values, that is elements of the array 1, 2, 3, 4, 5, and it's working. Simple, right? So let me have a printf statement here to distinguish the output from other things from the console window. So now let me make this num plus I. Num holds base address, I holds the index. Now it should print all the addresses from index 0 to 4, right? So let me show that to you. There's a very important concept here, so concentrate. So it prints all the addresses from index 0 to 4 with 4 bytes gap between them, because this A of 5 is integer type array. Now there are two important things to learn here, that is array elements are always stored in contiguous memory locations, and the second point, which is very important, that is a pointer when incremented always points to an immediately next location of its own type. So with that understanding, what will you get if you add 1 to the base address? So 1001 plus 1, you might be thinking you will get 1002, but that's not right. You will be getting 1005, which is the next memory location. Okay, so get this now itself, a pointer when incremented always points to an immediately next location of its own type, because A of 5 is integer type, integer holds 4 bytes, so the next memory location is 4 bytes after this, that is 100 plus 2 means 100 plus 2 into 4, that is 1009. Got it? So if you do base address plus 3, you will get 1013. If you do base address plus 4, you will get 1014. So if you do A of 4 minus 1, you will get 1013. Hope you get it. Please understand this concept. If you are confused, please visit the link I am showing you on your computer screen right now. I have explained the basic concept using a very small program, that is printing array elements in reverse order using pointers. In that I have explained this concept, and you can understand there, visually you can understand there. So please visit that link, pause this video and visit that link without fail. Okay, with that concept, let's move forward. So if I add star to it, we have an address at num plus I, right? So if I append star to it, it will start printing the values present at that address, which is 1, 2, 3, 4 and 5, and it's working. So now we usually write num of I, right? So which compiler converts into star num plus I, right? This can also be written as I plus num. Similarly, num of I can also be written as I of num. It works the similar way. Whenever you write num of I or I of num, it works the same way. So let us check that. And as you can see, it outputs the same result. So you can use those things interchangeably. So now let me take a pointer variable. Let me remove all these things. And let me take a pointer variable and point it to the base address, ampersand. I can just write num here, or else ampersand num of 0, which holds the base address. So instead of using num, I can use ptr. ptr holds the base address, right? Now let me increment the value of base address by 1 for each iteration of this for loop. So this should print all the addresses from 0 to 4, index 0 to 4. Right? Let us check that. Okay, it prints all the addresses. Look at this, 4 bytes gap. Okay, so if I append star to it, it prints out the value present at these addresses, which is 1, 2, 3, 4 and 5. So also note that I can simply add plus plus in printf itself. I need not write an extra statement here. It works the same way. Let me show that to you too. It will be helpful in some programs. Okay, that's working clearly. So now let me point. So these are the addresses. Okay, so let me point this to the last index of the array. Okay, so now I'll write ptr minus minus, so it should print all the addresses from the end, from index 4 to 0 in reverse order. Okay, so look at this. So 0, 8, 12, 16, 20 and 24, it's printing the address in reverse order. If you append star to it, so it will print the array in reverse order, 5, 4, 3, 2, 1, and it's working. So these are some of the basics of arrays and pointers. Please note this down, don't ignore it, and please stay subscribed to our YouTube channel and blog and you have all the notes on our blog, link to which is present in the description section of this YouTube video. So let's go further and use these pointers and arrays along with functions. Okay, so let me remove these things and let me have a function call here. I'll call it display and pass num of I. This is called call by value because we are passing value to this function display. Let me define this display method here. It doesn't return anything, so let me give it a return type of void. So it's accepting a value, so I'll take int of x. It's integer type, by the way, num of I. So I'll simply output the result here. So it's x, so it will pass the value elements of array one by one and it will display it. Right, this is called by value. Now if you pass address to it one by one, I'll need to have a pointer variable here. This is called call by reference. So using pointer variable itself, I'll print out the elements of the array and it's working. So if you remove this star, it will print all the addresses of these array elements. Let me show that to you. I know you already know all these things now by now. So let's write some programs, a simple program. Let us increment the value of array element by 1. So I'll take a function name like +1, or I'll take 1 plus, brand name 1 plus. So let me have a function here. It doesn't return anything, so void 1 plus. So it takes address, so I'll take pointer variable here star x. So you might get confused with star x, so let me remove this star x and x from here too to avoid confusion. So let me remove this display method itself. I can write this small function afterwards. Okay, so now I will do star x, which holds the value at address x, is equal to star x plus 1. Now manipulation takes place inside function 1 plus, right? But I'll be outputting all the values inside main method. So you might be thinking, since we are operating on addresses inside 1 plus function, it will reflect everywhere. You are right, partly. So first let me output it to the console window. So printf /t num of I. So it should output 2, 3, 4, 5 and 6 because we are adding 1 to all the elements of the array. So 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1 and 5 plus 1. So let's square it. Now need not take math.h library file. I'll just do a star x is equal to star x into star x. I want to keep it as simple as possible. Let me even include brackets here to avoid confusions. So now it will output 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. Nice. So you might be thinking we are using pointer variable and operating on addresses. So whatever we manipulate inside 1 plus function is reflected everywhere inside this program. That's partly right, but I want to convey you that these arrays are pointers in disguise. So let me show that to you. This is a very important concept. So let me remove this and rename it as display. And let me remove this. Well, let me remove this 1 plus from here and also this for loop. We don't need this. And this printf, get rid of this. Let me align this. So now I will be passing the base address of this array, which is present at ampersand num of 0, or else we can even pass the array variable name, which is num, both of which hold base address. Now let me write the for loop here. And then display all the elements of the array. So still I am using pointer here, okay? So just check this. So it displays all the elements of the array from index 0 to 4, right? So let's check that. Oh, we don't have macro here, so I'll just have 5 here directly, hard code it. That's not the right way. We could have macros here. This is a very small program for illustration purpose. So I'm directly using those numbers, that is size of the array, directly in for loop, okay? So this prints array variables from index 0 to 4. So we could even pass 5 here. If we had used macros, we could pass the macro template here. I'll take int of small letter n here to represent the size of the array. So we could use that in for loop like this. This is the standard way. So now it works the same way. So now instead of ampersand num of 0, I'll pass num, which also holds base address, right? So let us check that. So it still prints all the elements of the array from index 0 to 4. So now I'll remove this star and I'll write x of double parenthesis, big brackets. So this should work too. So we are not using pointers now directly. We are using still we are using pointers internally, but still it works. So let me check that once again. So it will print array elements from index 0 to 4. So as I showed you before, you could write x of I as I of x and it should work. So let us check that. It should output array elements from index 0 to 4 and it's working the same way. So we could manipulate the values of array elements inside display method and then display it or print it inside main method. Okay, so I'll write num of I. So inside display method, let me write x of I. It may not look like a pointer variable now because we are using array variable x, okay? So I'll do x of I plus 5. So let us see if it reflects in the manipulation actually reflects inside main method, okay? So let me compile this. Oh, I forgot equals to symbol here. So x of I is equal to x of I plus 5. And I need to write 5 here. and not n. So that's all. I guess this should work. So whatever we have manipulated inside display function is in fact reflecting inside main method, even though we are using arrays here and not pointer variables. That is because arrays are pointers in disguise. Whenever you compile this, compiler converts this x of I to star x plus I, so which is address, operation on address once again. So that's why whenever we operate on arrays, it gets reflected everywhere inside the program, and we need to take due care not to mess up with these array elements in any of the functions. In fact, if you want to do some operations and not alter the original array, you need to pass in a copy of your array to the function and not the base address of your original array. So these are the basics. Please note down all the things. If you have not noted down the things, don't worry, we have done that job for you. So please visit the link present in the description section of this YouTube video for source code, notes and discussion about this topic. Stay subscribed to our YouTube channel and blog, and please share this video with your friends on WhatsApp, Telegram, WeChat, LinkedIn, Twitter, Facebook, etc. And please do not forget to like this video on YouTube. Thank you.